Assalamualaikum and very good morning. My name is Hafizah Khalid with metric number S48544. Today I will be presenting non-destructive testing, radiography testing. Table of contents: theory and principle of operation, working procedures, advantages and disadvantages, and last one is example of application. So what is NDT? NDT is a testing and analysis technique used by industry to evaluate the properties of a material, component, structure, or system for characteristic differences or welding defects and discontinuities without causing damage to the original part. In NDT, radiography is one of the most important and widely used methods. Radiography uses penetrating radiation that is directed towards a component. Theory and principle of operation. Radiography testing is a non-destructive testing method which uses either X-ray or gamma rays to examine the internal structure of manufactured components, identifying any flaws or defects. In radiography testing, the test part is placed between the radiation source and films, or we call detector. The material density and thickness differences of the test part will attenuate or reduce the penetrating radiation through interaction processes involving scattering and/or adsorption. The differences in adsorption are then recorded on films or through an electronic means. In industrial radiography, there are several imaging methods available, techniques to display the final image. In radiographic testing, the part to be inspected is placed between the radiation source and a piece of radiation-sensitive film. The radiation source can either be X-ray machine or radioactive sources. The part will stop some of the radiation with thicker and more dense areas to stop more of the radiation. The radiation that passes through the part will expose the film and form a shadowgraph of the part. The film darkness or density will vary with the amount of radiation reaching the film through the test object, where darkest area indicates more exposure or higher radiation intensity and lighter area indicates less exposure. This variation in the image darkness can be used to determine thickness or composition of material and will also reveal the presence of any flaws or discontinuities inside the material. General principle of radiography testing. The energy of radiation affects its penetrating power. Higher energy radiation can penetrate thicker and more dense material. The radiation energy or exposure time must be controlled to properly image the region of interest. Next one is working procedure in conducting radiography testing. First of all, we need to understand the codes, specifications, customer requirements thoroughly to develop a technique based on the thickness and type of material. We need to prepare a shooting sketch. In a dark room, carefully place the radiographic film in the cassette with the proper lit screens and place the film under the area of interest. Ensure that the correct source to film distance is being employed and place the appropriate station markers and identification numbers in the area of interest to assure easy correlation with discontinuity if one is detected. We need to set up the exposure parameters, make the exposure in the dark room, unload and process the film, evaluate the film for artifacts and for compliance. The last one, complete a report and store the film. Advantages and disadvantages in using radiography testing. Radiography testing will provide pictorial result and documentation ability. The one result of the inspection can be reassessed by different professionals, detection of internal defects, and also variance in composition of materials, thickness, measurement, etc. It also can be used for all types of material. The disadvantages of radiography testing consist of requires special skills for interpretation of pictures and also specific orientation. Radiography testing is expensive and also dangerous. It is ineffective for pana cracks and not good for surface defect. Example of application in using radiography testing in ship repair process. The first one is pressure vessel inspection. The failure of a pressure vessel can result in a rapid release of amount of energy. To protect against this dangerous event, the tanks are inspected using radiography testing. Industrial radiography testing makes use of X-ray or gamma ray radiation to create images that can show defects hidden inside the material. This technology is widely used to ascertain material integrity of welds, casting, piping, machine parts, pressure vessel, and other objects. The method is fully non-destructive and surface preparation of the test piece usually isn't necessary. In many cases, RT can also be used to inspect industrial installations that are in operation. X-ray testing is possible for material with a maximum thickness of 50 mm, and gamma ray testing is possible for material with thickness varying from 10 to 120 mm. Radiography inspection of hull wets. A non-destructive testing method which reveals internal defects in metal by exposing film to X-ray or gamma ray passes through the metal. Radiography inspection of hull wet is to be carried out mainly in locations such as intersection of butts and seams in the shear strakes, bilge strakes, deck stringer plates, and keel plates. These are the references that I will use to prepare the presentation. That's all for me. Thank you.